we've got two approaches here. We can either just specify an undercut, say give it a radius of 1 millimetre, so it's 2 millimetres deep. They've got an abutment radius for shafts and housing in millimetres of 1 on there, granted, okay. Is that specified?
It's SKF.
Okay, so it's SKF, so we've got 1 millimetre, so we can have a radius of 1 millimetre, if we so wish.
I think we could...
If we can check the catalogue, here it says 1.2 for the one we've chosen, okay?
Okay, yeah.
Okay.
So we can try 1 millimetre, that's a lot
Now
bigger.
we know we can do that. What we need to do is we've changed
Yes, there's the size.
the size now.
Go for a bigger shaft anyway.
We need a bigger shaft.
And
Now
we
the
work
issue is,
out
of
the-
course, is that in choosing this new shaft we are taking into account a much larger stress concentration factor. Now if you could, because the stress concentration factor is
So this is
intrinsically,
not talking about the undercut.
we don't need an
design.
undercut if we can have a
Try
radius.
this, yeah. We
It
try
will
the
allow a certain
long.
radius of 1 millimetre. Now the issue is of course that the in choosing what we're doing at the moment is we're working backwards. Is we're actually saying we have on the spreadsheet a link between the diameter, from that the second moment of area and the poly moment of area, and from that the bending and torsional combined stresses. But one of the issues is of course is that also the factor, in terms of the N, the complete design factor, K changes with changes in
The
diameter,
size,
and
yeah.
that's not catered for in this spreadsheet as it currently stands.
No, but we can...
But what I want to know is if we have these
Can
diameters,
we- Yeah, can we start with assuming a 2
okay,
for K?
K of 2, okay,
Yeah. And then
Okay.
we select, then we go back and...
and that
double
gives us a
check that.
much higher. I mean, if I just go back,
Yeah.
if I just what I had before, so if I go to originally it's 2.9, and that gave us a maximum allowance stress of 2.95 times 10 to the 7. If we go to 2,
2.9 is too big.
that's 4.27. Okay, so we're much bigger than we need to be in terms of the shaft. So if I go back to 80, we're still inside at even 80, so it makes a lot of difference. Okay, 80 again,
Yeah.
70. These are all
That's
comfortably inside what they need to be. Okay,
Mhm.
now can we work out K again properly, taking this geometry?
Okay, so what our big D is 80 now,
Yeah,
Small
small
d.
d is 70.
70. Okay?
And we have a radius of 1, so d upon d is 8.7 basically.
Yeah.
D upon d,
Okay, 1.14.
And
And
radius
one-
upon
1 mil. Can we
1 divided by
70? The small D.
is,
It's still quite small.
yeah. Now what we could do is let me look in the catalogue, because the bigger bearings, let me just choose the bigger bearings, they will allow us a bigger radius, okay? So let's just go back into here, we're going to say we want the product table, okay?
Yeah. The core
Now
diameter.
what we want is we're looking at,
70.
the one that's key is the deep groove ball bearing, okay? That's where it's all failing. If I understood it correctly, or is it at the pulley?
Pulley.
Okay. In which case, why are we looking at bearings?
I think we're looking at...
I think we can have anything we want for the. No, the place where it fails is at 3.
Yes.
Okay.
That's the worst.
Which is the pulley. We can have
Biggest
whatever we want for the pulley. We can have whatever radius we choose because we're machining it. We start with a blank, essentially, pilot hole, and we machine it.
Yes.
Right, that took us a while to figure, didn't it?
So we need to check the bearing as well for
But this is,
note 2.
yeah, this is comfortably within what we need. This is 1, 2, 3, 8.9 times 10 to the 6. We're allowed 42 times 10 to the 6, basically. So it's comfortably inside.
Even with a step shoulder
Oh, well,
stress concentration.
yeah, I mean, but if I put this back to what it was originally, so call that 3. Okay. Still 2.8, it's still 28, and we only have 8.
Okay.
So it's fine at that end. It's at the other end that we have issues. Okay. Now, I think we make the radius quite large. We can make it,
For the pulley, there's no restriction.
because we're manufacturing the pulley.
So we can have just
Machining up
5
pulley.
mil.
How do we machine? No, it's easy. Yep, so we're going to try 5 mil. 5 mil radius.
5 mil over 70, yeah?
Yeah.
0.07, yeah?
Mhm.
D over D was 1.14.
So we're up to 1.7, are we?
Yep.
So we put 1.7 in here, and we'll see what happens when we have 1.7. 1.7 gives us an allowable of 50 times 10 to the 6, okay? I mean, we could even start dropping the diameter back down because we're only at 3.
Probably a lot higher than we
We're at 5. Oh, actually, so we're at 38 times 10 to the 6 here.
Okay.
And this is, we're around 50. So I can drop here a
Drop
bit.
that to
75.
Yeah.
That's 46, yes, we can have 75. Try 75 to 65.
65. And radius of 5 again by 65. What? 1.15. 1.08. Somewhere about less than 1.7.
Just leave it at 1.7 as the worst case. But we're actually within that. If we had 65, 75, 75, 65, diameter of the nose,
We're still
we
okay.
have combined of, at the pump of 4.5 times 10 to the 6. At the pulley we have 46 times 10 to the 6. At the ball bearing we have
But the most critical
10
is
times 10 to the 6. We're allowed 50 times 10 to the 6. The one that's closest is a pulley, and that's 46 times 10 to the 6, and we can have 50 times 10 to the 6 with that stress
Are we happy with
concentration
that?
factor. Yes, now we just need to go and choose bearings of this size.
Yep.
Now they're
for
going
the
to be
65.
vastly bigger than we need. Okay,
This is 75 by 65, yeah?
so wide tech, we're going to go for the bearing units, cast housing, eccentric blocking column, is it? Okay, so the diameter we need,
65. What ball?
how would you believe they don't do that? They do 60.
There's no. We could have a bigger step. Which
Right, let's have a little look. At that bearing we're quite easy, I mean, we could even
do we
have
change that to 60 and see what happens? Yeah. Keep that to 75.
60.
Sorry? So you have 50. 7.5.
Sorry, we're doing it wrong here, because it's actually a small diameter here. So we've got, no, because we haven't said how big this is. Anyway,
No.
how big is that? Have we been working this out right? Sorry, mate.
Yeah, I think we have. Not actually. Because this one is.
The larger, that should be 75, and that's 65, that bearing sits on. The pulley's a bit smaller here. The bearing there's a bit smaller. I'm getting very confused what we've done.
I think, okay, basically we have to start again. Yeah. We need to work out the step at each node, yeah?
Mm-hmm. Yeah. I think what we lost is that when we have a diameter, we should have a smaller, larger diameter at each node. Because we only have 2 diameters, we should have 3.
Okay, D over D for the motor and what should we start that with?
Well, the thing we need to
We need
there's-
65 here. We need 65 is only 5 here, so
Yes.
this